Hi everybody. Today I'm going to talk to you about my favorite method for vector addition, and that's the component method. It does assume that you have a pretty good grasp on right triangle geometry. So I'm going to assume that you understand the Pythagorean theorem, the sine function, the cosine function, and the tangent function. If any of those are either unfamiliar to you or if they are just kind of a hazy memory, you're going to want to watch the refresher video I'm going to post on the Classroom. I will likely pull one off of YouTube rather than do one myself, since there are many, many good ones on YouTube that are probably better than what I could do. But for the purposes of this, I'm going to assume that you understand it already. If that's not the case and the video's refreshers don't help, you're going to need to talk to me about it. So I'm going to ask that you be proactive and try to let me know. If you don't get it and you just keep going through this and trying without any help, it's not going to end very well for you. So I want to make sure that things go as well as possible for everyone involved. Okay, so with that in mind, we're going to add these two vectors together. Let's call this one vector A and call this one vector B. It doesn't really matter what kind of vectors they are. I just drew them out. Let's say they're displacements, but it doesn't really matter. You may notice that I've drawn them on a north, east, west, south coordinate grid here. And so you can see that both of them are going roughly in the northeasterly direction. Not exactly northeast. Northeast is actually exactly 45 degrees, but roughly northeast. And so we're going to use that information to be able to try to figure out what the vector sum would be. So my goal is to take A and add it to B and find out what the resultant would be. And I'm going to leave that as a capital R so that you see that it's a resultant. So my question for you is, what method could I use? Now, from the last video, you know you could use the parallelogram method, which is fine. It's okay. It's not great in my estimation. It has some limitations to it. But I'm going to use a different method. I'm going to use the component method. Now, a component is really the idea that you're going to take any angled vector and convert it into the horizontal part. So this is the horizontal part of it and the vertical part. So any vector of any kind, let's say that's A right there, can be converted into the horizontal and the vertical components that it has. So these two are considered the components. Now our strategy then is to take the components of all the variables involved, in other words the components for A and the components for B, and add them together and then use them to be able to assemble the resultant. It's really not that tricky as long as you understand the sine, cosine, and tangent and the Pythagorean theorem. So here we go. Let's take a look at vector A here. Wouldn't you agree that between, if these are displacements, between the reference point and this point at the end, the object could do whatever it wanted to, we just know that it ends up right here. So let's imagine the simplest possible case is that it goes all horizontal for 4 meters, and then all vertical for 2 meters. Okay, so I'm going to call this part of it A sub h to indicate that it's the horizontal part of A, or the horizontal component of A. I'm going to call this one A sub v to let you know that it's the vertical component of A. I'm going to switch pen colors so I can do the blue one here. Now we're going to add to that this blue vector. I probably should have drawn that in blue right there, so that helps you a little bit. But again, we're going to break it down into its horizontal and vertical components. So starting here and ending there is the same as going vertically up, or north, for 3 meters, and then horizontally east for 2 meters, right? And so I'm going to call this part B sub V, and I'm going to call this part B sub H for the vertical and horizontal components. Hopefully you're with me here so far. So here's the question. How can I use the components to be able to add the vectors together? Well, as I said just a minute ago, anytime you have A that's at an angle, you can break it down into its component parts. So instead of saying A, I could say A sub h plus A sub v, and mean the same thing, because wouldn't you agree, these two vectors get you to the same point that that one vector would. I hope that makes sense. Now I'm going to add that together with b, but b is kind of the same thing, right? I'm going to go ahead and break it down into its horizontal and vertical components. So b sub h plus b sub v. And together they're going to give me the result. Again, these are vectors, so you want to make sure I'm not just adding them together. I can't just add them, right? Because these are different kinds of vectors here. So you might remember in algebra class that whenever you're going to take things that are not like terms and add them together, you have to try to sort out all of the like terms and combine those first. And so in this case, we have two horizontal vectors and two vertical vectors. So we're going to break those two horizontal vectors out, put them together. A sub h plus b sub h. And I'm going to add those two to the vertical vectors over here. And so I've got a sub v plus b sub v equals r. Easy enough so far. Okay, now I can start to plug in those numbers. So a sub h is actually 4 meters to the east. So I'm going to put that in there, 4 meters east. And sometimes whenever I write a direction, I typically circle it so you know it's not something else in there, right? E, capital E could be energy and lots of other variables, so we don't want to really deal with that. So I'm just going to circle it to let you know it's east. B sub h looks like it's 2 meters to the east. So 2 meters to the east. And then I'm going to add that to a sub v, which is 2 meters north. Plus b sub v, which is 3 meters north. And together they're going to give me the result. So I combine them up. So I get 6 meters east plus 5 meters north equals the result. Okay, so, okay, great, excellent. Is it the answer 11? No, of course not, because this is east and that's north. So I have to add them together as if they were a right triangle, right? So this is an A leg, and this is a B leg, and this is the hypotenuse, is really what's happening here. So whenever I have an A leg plus a B leg, I'm really asking you to do the Pythagorean theorem. And so really what I'm saying is that the triangle looks like this, right? If I were going to draw it out, it would have to go 6 meters east and 5 meters north. And the resultant would be this guy right here, and that's r. So you can see it's not going to be 11, right? That doesn't make any sense. You can also see that it's going to be generally in the northeasterly direction, but we'll have to try to figure out what that angle is as well. Hopefully you're with me so far. Okay, so to figure out r, I use the Pythagorean theorem. So a squared plus b squared equals c squared. So to figure that out, I'm going to say r squared equals 6 squared plus 5 squared. So r equals the square root of 36 plus 25. And unfortunately, my brain, she's not so good. So let's see, that's 61, right? So 61 square root gives us 7.8. And I will leave us at 2 sig figs there. So 7.8 meters is the magnitude, right? It's the magnitude of this. It's how long it is. But it doesn't tell us anything about the angle. How would we figure out the angle? Well, if you remember correctly, the tangent function, tangent of theta, is equal to the opposite side divided by the adjacent side. And so the inverse tangent of the opposite side divided by the adjacent side should give us what theta is. Okay, so I'm going to go ahead and do that out. I do not have the tangent functions memorized. Surprise, surprise. So I'm going to try to answer this here real quick. So 5 divided by 6 equals that. And then I want my inverse tangent. There's my inverse tangent. This is a weird, there it is. My Windows calculator skills not so good. So there you go. So 39.8 degrees. Let's go ahead and call it 40 degrees since we only have 2 sig figs on this. So 40 degrees. Now, wouldn't you agree that this is the east axis and this is up to the north? So it must be north off of the east axis is our answer. So if I wanted to tell you what's the resultant vector and give you all of the important information about it, I would have to give you both of those items. So hopefully that makes sense. The vector addition is really not terrible, but it is something it can be a little trickier. So just be careful with it. We're going to do a lot of practice on it. So, but the more you start thinking about things that are complicated as broken down into their horizontal and vertical motions, I think you're going to be better off in the long run, especially when we get to the actual projectile trajectories. Really, if you break it down into horizontal and vertical, it makes a lot more sense. Hope that helps. If you have any questions, let me know. Thanks.